Welcome to MSE 331, Experiment 1 Part 2. We're going to be taking our samples that we made last time and we're going to try to polish them. So first step is we have to take them out of these mounts. So we're going to use this punch and die set. Here's the punch, here's the die. The proper setup for this is, it's pretty simple. You grab your sample in the mold, you put it on the proper sized ring, you put the flat end on the sample. That's very important. You'll break the die if the flat end's not on the sample, and then you can just punch it out like. Ooh. And here's your sample. Okay, so now that your sample is out of your mold, you got to clean the mold. To do this, you're going to need safety glasses and gloves, and you're going to be using acetone. I'm not going to do it in this video, but come Thursday/Tuesday, you're going to need to know how to do it. Okay, once your mold has been cleaned in the side, you have your sample. We're going to be marking our samples with an engraver right here, and make sure you memorize what's on your mold, because you're going to be putting that on your sample. I already did this one. It's 70 BI. So that's what. Here we are in the polishing room. We are trying to polish this sample of 70 bismuth 30 tin. There are many steps that you have to do. First is make sure the water's turned on. We're going to start by polishing this sample with this rough grinding wheel. Turn on, turn off, green, red. Make sure the water is on, because that'll keep the sample clean while you're sanding it. And not only that, it helps reduce like friction and like bad scratches and all that good bad stuff. So when you're polishing, try to keep it level. Try to keep the sample level while it's on. Try to keep it as flat as possible. Grinding this down, we're trying to cut half of it off. Try to get to the middle of the polish, or of the sample. Not of the epoxy, but of the actual small ingot of metal in the middle. We're trying to get half of that. And with this, the edges are now beveled, and yeah, you can go start the fine sanding. Okay, so here's a sample after we just went off the grinding table, and now we're trying to do fine grinding on these sanders. So there are 4 different types of sandpaper here. It goes from 240, 320, 400, 600. And obviously, as you get more fine, the scratches also get more fine, and it's just leading you up to go to the polish table so you can get rid of all the scratches altogether. But we're going to start at 240, obviously, and it's very important that in between each step, you clean the sample. And this is to make sure that all the silicon carbide, which is the sandpaper, does not get into the sand or into the sample. Okay, before I get started sanding this on the 240 grit paper, you can go in your first direction and you're sanding it, and then you'll get these lines. They'll be parallel to each other. You're going to want to rotate your sample 90 degrees and try to get lines perpendicular to those lines. Again, it's very important to make sure that your water is on to keep the sample clean. Okay. This, as far as I can tell, looks pretty good. It's still flat, which is a good sign. And now all we have to do is clean it. Okay, now that we've used the fine grinder to grind this down a little bit, we still have to clean them. Cleaning them is important because it keeps silicon carbide out of the sample. Here we're going to be using cotton balls, this bar soap, and ultrasonic cleaner. First step is obviously turn on the water. You're going to get the cotton ball wet. I'm going to run it on the bar soap a few times, get the soap off the bar on the cotton ball. Then you literally just clean the sample. Now my thing, how I know when it's done is when there's soap over the edges of the, or over the bevels on all sides, that means it's pretty much done. So, and you clean it off. Okay, now that that's done, ultrasonic cleaner, there's water in it. Turn it in there, make sure it's plugged in. Turn it on. Oh, there it is. Rub it around, keep it in there. Shouldn't have to keep it in there for more than a minute. Okay, now that you've cleaned it, dry it off with the arrows. Make sure when you're putting the samples on the microscope that it's completely dry, otherwise you're going to damage the microscopes. So far we've polished this sample up to 600 grit on the sandpaper. Stage 1 was using this rough grinder, and it goes up to 120 grit. 2 was with the 240, and it ended 5 being 600. Obviously going through 320 and 400 grit, polishing it, cleaning it, and rotating it each time. Now we're going to do 600 grit on the polishing. So here we are at the polishing table. We're trying to polish this sample. We'll start with 600 grit. The purpose of 600 grit is that it is really supposed to just get rid of all of the silicon carbide particles that were from the grinding stages. And so this is a 600 grit alumina. To start this, you shake up the container because it's powder and water, so you gotta keep it, make sure it's mixed, and then you can just turn it on. I like to run mine somewhere around 150 RPM, and then you just spray it on, and then like that. Now you can get to grinding. Now, when you're grinding, try to move the sample, like not only just move the sample, but like rotate it as well so the alumina gets everywhere. It's slowly refining the scratches, making it a little less. But again, 600 grit, it's really, its main purpose is to get rid of the alumina, silicon carbide. So we're almost done polishing using these polishing wheels. Remember, you're going from 600 grit, moving to 5 micron, moving to 0.3 micron, and each time you switch from one table to the next, make sure you're cleaning it like how I said before. It's important to make sure that all the alumina, just as the silicon carbide, is not in the ingot itself. While 600 grit's purpose is really to get rid of the silicon carbide, 5 micron is where you really start to see the scratches go away. So if you're thinking you're done with 5 micron and you still see scratches, you're not done. But if you see like a single small scratch off, yeah, you should probably, you will most likely be good. You can just move on to 0.3 micron. Make sure that you're using the right alumina per table. That's really important. And the water is right above the table for each of them. So if you need water, there, turn them on. Last note, Make sure you're at your station. We didn't put up the signs for nothing. This is MSE 331. Have a good day.